Hello everyone, welcome back to Pre-Algebra with Miss Betsy. I'm glad that you're here with me today. We're continuing on with our discussion about distance problems, motion problems. This is part 2 of a 3-part teaching, and we're dealing here specifically with rate times time is equal to distance types of problems. If you happen to be using our text, which is Pre-Algebra for Christian Schools by Bob Jones University Press, you can follow along with us. We are in section 4.9. I'm working from page 164 of our text today. But before we get started, I'd like to know if you can answer this riddle for me. I'd like you to name for me 6 animals that would be inhabiting the Arctic regions. And I'll give you just a moment to see if you can come up with what those are. And I'll tell you the 6 animals that I came up with now. Well, that would be 3 polar bears and 3 seals. Now, nowhere in my question did I ask you to give me 6 different animals. So yes, you may throw things at me now and groan, and it's the advantage of being on this side of the screen from you. You cannot get to me with the rotten tomatoes. I want to go ahead and pick up with this full board of information that we have. This goes back to part 1 of our teaching, and I had dropped off at the end where we had a problem that was dealing with the difference in times that a junior high and a senior high school class had been hiking. Let me pick this up and reread it to you. It says, the junior and senior high Sunday school classes are going on a hike. The junior high class leaves the church and travels east at 3 miles per hour. The high school class leaves an hour later, traveling at 5 miles per hour on the same route. How much time will pass before the senior high class catches up with the junior high class? We spent quite a lot of time developing that problem and figuring out that what they were actually asking is, how long does the senior high class hike? So when we set up our original problem, we said, let x be the amount of time the senior high class rates, and then let x plus 1 be the amount of time the junior class hikes. And we said x plus 1 is the amount of time the junior high class hikes because our problem specifically tells us that the high school class leaves an hour later. So if the high school class left an hour after the junior high school class left, then the junior high class has obviously been traveling 1 hour longer. We went through and created our rate times time equals distance table to come up with the distance that the senior high class had traveled was 5x. The distance that the junior high class had traveled was 3 times the quantity x plus 1. They both traveled the same distance. They traveled differing amounts of time, but they traveled the same distance. So we set those 2 distances equal to one another, and we came up with x being 3/2 hours, which I said to write as 1.5 hours. 1.5 hours being the amount of time the senior high class hiked, and that's how long it took for them to catch up to the junior high class. And at the end of that video I said, you know, there's another way you can do it. Let me show you what that looks like. And this is what I've done here in the blue. Here we set it up and said, well, let x be the amount of time the senior high class hikes, because that's what it asks for. So it makes the most sense to say, let our unknown, let our variable represent exactly what we're looking for. But let's say that you had a blonde moment, or just a brain freeze, or you've been up way too late the night before and you thought, well, I think that I'm going to have x represent the amount of time the junior high class hikes. And then I'm going to have to figure out, okay, how long did the senior high class hike? Well, the junior high class left first, so the longest amount of time is the amount of time that they travel. Because the senior high class left an hour later, if I take 1 hour less, or x minus 1, that would give to me the amount of time that the senior high class hikes. So, I'm not quite sure why I used red here. I guess it's too early in the morning. This red table over here represents the second way of doing this. Now, is this the best way to do it? No, because the easiest, least convoluted way to solve word problems is to have your variable stand for the quantity that you are attempting to determine. We don't really care how long the junior high school class hikes. What we care about is how long the senior high class hikes. So I've actually introduced an extra step in here, but I want to show you that you can still solve the problem this way. Okay, the junior high class travels 3x miles. The senior high class travels 5 times the quantity, x minus 1 miles. Because the junior high class travels 3 miles an hour, senior high class travels 5 miles an hour. You multiply rate times time to give you the total distance that those two groups of people have traveled. Because they meet up with one another after having left from the same place, having left from the church, their distances are equal. So we have 3x is equal to 5 times the quantity, x minus 1. We solve through that, and we find out here that x is 5/2 of an hour, or 2.5 hours. Now, that doesn't make sense at first, maybe because you say, look, Miss Betsy, it says 1.5 hours over here is the variable. 2.5 hours over here is the result when we do it the second way. Well, that's why I have to go back and see how you defined your variable, how you set up your problem. In this first one here, we said x is the amount of time the senior class hikes. The amount of time the senior class hiked was 1.5 hours. That's your solution. But let's look over here. How come this is 2.5 hours? Because we imprecisely, or perhaps unwisely, decided to let our variable in the second example here be the amount of time the junior high class hikes. Did our problem ask for junior high? No, so it's not the best thing to figure out junior high class. However, if you know how long the junior high class hikes, and you know that they hiked 1.5 hours longer than the senior high class, right here you substitute in 5/2 or 2.5 hours minus 1 hour, and you see that even using this little bit of convoluted way of representing things, you still have that the senior high class traveled for 1.5 hours. And that's what I wanted to show you in part 2 of this video. So I'm going to go ahead and conclude this one, and I'll come back to do another example for you.